Hi guys, and welcome to part 2 of the interactive fog tutorial series. Now this part's taken me a little bit longer to get out as well than I promised last time. I'm just going to stop making promises about when the next part's going to come out. It will be soon though. I've just been really busy still. So yeah, anyway, we'll get into this one and we'll talk about where we left off last time. So when we finished the last video, we had this fog here, which is a particle system writing to the fog, and we have a fall off from the ground in a basic fog material that we created. Something I didn't talk about at the end of the last video, which I'd just like to touch on, is why we use a particle system. It just seems to be a lot cheaper than using a mesh to write to the fog. Now, I'm not sure why. I'm not sure if it's to do with the fact that we're using a 2D sprite, really, but it's a lot cheaper. And also, you may notice that this is obviously a sphere because our particles bounds is spherical. So before we do anything else with the material, we're quickly going to have a look at how we can just create some different shapes, and then we'll move it into an actor so that we can have easier control over everything that we're doing in the material and moving forwards. Then we'll talk about the sort of height offset using the scene capture and distance fields, move on to adding the noise and the curl noise and a bit of self-shadowing. And then that'll be the end of this episode. And then in the next one, we'll have a look at implementing the actual interaction and the interaction capture and that sort of thing. So we will move on to talking about defining some more custom shapes now. When it comes to defining custom shapes with this fog, we have sort of 3 options really, or 4 if you want. One is just to allow the particle to actually clip, how we are now, and using the particle radius to define a spherical fall-off. Or we could describe shapes like a box or a sphere mathematically, which is what we'll look at in a minute. And we can also use a texture or a volume texture to create the shapes that we want. So we're going to just quickly have a look at doing this. So what we're going to do is we're actually just going to unhook what we've done here. And we're just going to have our extinction value set back to 1, just so that we can easily see the outlines of the shapes and we're not messing around with fall-offs and throwing off the shapes and that kind of thing. So just let that compile for a second, and now we have the sphere that we had before. And all this is doing is, this is just a 1 extinction, so it's a sphere because we're hitting the edge of the bounds here. So if we wanted to define a sphere mathematically, which we'll do now, that's the most simple shape that you can describe mathematically, because a sphere is literally just a certain distance from its center point equals the surface of a sphere. So its radius from the center point will always equal the surface. So it's literally super simple. And to do this, we will get the absolute world position. We'll just copy this over here and just move this off for a second. And we want to get the distance of this from the center of our particle. So we'll also grab our particle position again. So world position, subtract particle position, and if we take the length of this vector, that will give us the distance. So this will return as our distance. If we then divide this by a sphere size, we'll set this to 200 just for now. Divide that by a sphere size, sorry. Then that will actually give us a fall off 0 in the center and 1 at the outside. So we want to just saturate this and 1 minus it again. This will then, if we then multiply this by our extinction value here, which we don't need to do if this is just 1, but we'll do it anyway, and apply that. If we open up our instance, we now have this sphere size property, and I'll also put real time on. Let this compile, and you see we have a sphere again, but this time we just have a definable size, and we haven't added any controls to adjust the fall off, but that's as simple as adding a power node in there as we did before. So that's a sphere, but you may also want a box, because a box is also a pretty useful shape to have. If you want to just fill a square or a rectangular room with this interactive fog, then a box would obviously make a lot more sense than a sphere. So we'll do that. There is 2 ways we could do it. We could actually do it using the nodes in the material graph, or we could do it using a custom node. So we're going to actually do it using a custom node, but it's not something that you should be scared of. HLSL is super easy, and for defining a box, it's really simple. So All you need to do, even if you don't understand, is just copy exactly what I'm doing here, and then you'll be able to define a box. So I've just got Notepad++ open here. Use any text editor you want, because if we actually add a custom node in here, you'll see this is our code window that we can actually edit our code in, and it's not great. It doesn't allow you to start new lines or a lot of stuff. So really, you want to write your code outside in a text editor, or you could also write it in a comment here if you wanted and just paste it in. But using a text editor is better, especially if it's something like Notepad++, because it has coding support. Unfortunately, it doesn't have support for HLSL, which is a little bit annoying. It's like the one language it doesn't support, but it doesn't matter. This is really simple anyway. So to define a box mathematically, or at least to know if we're inside or outside of one, all we need to know is that if our distance in any one of the axes, any direction x, y, or z, is greater than half the size of the box, then you're outside of it. So for this, we basically just need an if statement. It's a complex if statement, kind of, but it's fine anyway. We'll look at this now. So to define an if statement in HLSL, it's literally as simple as just typing if, and then we put our if statement in brackets. Then after this, we'll have our code in here, and that will basically be it. So for our if statement, let's just close that because it's going to annoy me. In our if statement, we'll just worry about the x direction for now. So we'll say if our world position, now this isn't how you just retrieve world position straight away. We're naming parameters here, so we'll feed these in to the custom node. So if our world position dot x minus our particle position dot x. Now we also want this as an absolute value. We don't want it to go negative. So if we just type ABS absolute here and then put this in brackets. So if the absolute distance between our particle and our current world position is greater than our box size, which will also feed in as a parameter, have that capitalized, is greater than our box size dot x over 2, and we'll bracket this as well, which isn't necessary, but just for the sake of neatness and it's easier to read. So if the absolute world position x is minus particle position x is greater than half of our box size, then we know that we're outside of here. So if this is true, then we will run whatever's inside here. So if this is true, then we will return 0, right? Because we're outside of the box here, so we're 0. And then else, so if this isn't true, then we'll run this instead, and we'll just return 1 and close bracket to close that off. And then this is the first, so this is the x component now. So if we copy this, paste this into our custom node, make sure that our output is set to a float 1, and we'll add our inputs. So there's already 1 added for us, but we'll add 2 more, and we'll call these what we've named the parameters. So world position, these are case sensitive as well, so you need to make sure that you're aware of that. Particle position, and our box size. Now you'll notice that the box size input, because we're retrieving an x component, that means that it's actually a 3-channel vector, because that will allow us to then define rectangular shapes, not just perfectly square boxes. So that should be everything we need for this. So if we plug our absolute world position in here and our particle position in here, and we create a new parameter and call this box size, and we'll just default this to 100, 100, and 100. It'll be a little small maybe, but, and multiply this by our extinction. Click apply, and if you've copied that correctly and everything's right, then you shouldn't get any errors. Just let this compile for a second. Okay, so now you can see that in the x direction we just have a 100 unit slice, which is exactly what we wanted because we're not caring about the other directions at the moment. So this creates as a kind of disk. So if we want to include the other directions as well, then we just need to extend this to be an OR statement. So we'll copy what we have here, just inside these last two, inside these brackets like that. And then in here, we'll space, and then we'll do a double upright character. I'm not actually sure what that's called, but that's how to define an OR statement. So 2 of those, and then we'll paste this in, and we'll change this to Y, 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 and Y. And then we'll do the same thing here, double upright, space, paste this in, and change this to Z. So Z, Z, and Z. And now we'll just copy that, paste it back into our custom node. See if we get any errors, which we shouldn't. No, we haven't. And then click apply to compile. Let that compile again for a second. And now we should have a box, which we do. So if we go into our fog instance here and have a look at our box size parameter. So if you drag up our red channel, then we're going to extend in the X direction, and green in the Y, blue in Z, obviously. So this is how we can define a box very easily as well. The other method is, of course, using textures. Excuse me. The textures are quite simple, so we'll just grab this one. So this is a 2D texture, and then there's also, of course, a volume texture that we can use. Apologies if you can hear whatever that is outside. Someone's decided to like mow the car park for some reason. Right, grab this. So if we're mapping this, there's 2 ways we could map this to our particle. So in this case, it's a star texture. So we want to align the center of our texture with the center of our particle. Now, we can do this in a couple of ways. We can map it with world position, or we can also use a bounding box-based 0 to 1 UVW. So what that does is it just creates a 3D UVs inside the bounds of our particle or our mesh. So it'll be 0 to 1, 0 to 1, 0 to 1. So all we care about here is the R and G. So we can just append these together and put this into the UVs. And we'll just take the red channel, multiply this by this. Now, I haven't tested this with a particle. This works with a mesh, but if this doesn't work with a particle, then we'll map it using world position. So this is a bit of an experiment. Allow it to compile once again and just see how that's done. Okay, so that's done something. We can see here that we've got some chunks missing. But that's not exactly the result that we wanted. So I'm not sure actually if this is just because this is much bigger. But it doesn't matter anyway. We'll use world position. So to do this, we will once again take our world position. We'll mask out the red and green channels because we only care about the top-down perspective here with a 2D texture. We can then apply a height-based fall-off to the, if you were using a star shape, for example, to modulate the Z component. So we take the R and G, and what we want to do is find the bounds. Find the bounds, object bounds, or there might even be a particle bounds. Is there? Particle size. We could use that. Okay, so our particle size. Now, if we divide this by this, then that would give us a 0 to 1 across our particle size. However, this will be centered, or the top left corner of this texture will be on the center, because that is the 0, 0 at that point. So we need to offset this before we divide it. So we'll just take the red and green positions, and whoops, what am I doing here? And we will subtract half of this particle size. So we'll take this and we will divide it by 2, and we'll subtract this and then divide it. So what we're doing is this top left corner was offset into the center. So by subtracting half of our size, i.e. this much, we're pushing that top left corner back up into the top left. And then obviously by dividing it by the particle size, we're mapping it 0 to 1 across the entire particle size as well. So hopefully this will have worked. See if that's worked any better than the other method. And then we'll go on to talk about volume textures in a minute as well. Okay, so that's more like it. So if we look from the top, we can now see that we actually have a star. Now, it's a kind of weird shaped star for some reason, but it's still being mapped to the world position, that's why. So that's my mistake, I'm sorry. There's something that I did wrong in here. Just give me 1 second, I'll just fix that really quickly. Apologies for that, Kurt. That was me just having a complete brain fart for a minute there. I forgot that we, of course, need to subtract our particle position from our world position first before we do this calculation so that it's actually relative to the centre. So just make sure that you're doing it that way. And then that means that now we can move this around and it's this star will stick to it. So we can, of course, write to the fog using volume textures as well. So this 2D texture here, you can just right click and click create volume texture if you have a sub UV texture like this, and that will create you a true volume texture, and then you can just drag this into your fog, and we're going to sample this in exactly the same way, but we just need to make sure it has a Z component as well this time. So if we just copy this and we take our particle size and that, make sure that we append many. We'll just create one vector from this, and because this is a scalar value, so we need to make sure that this is a float 3, so we're doing this, and we also need to make sure that we're not masking out any of these channels. And then if we plug this into the UVs here, and we'll just take the red channel, plug that into our extinction value, and click apply, and now we should have sort of a wispy ball looking thing when this is compiled. Yeah, and there we go. So that's the wispy kind of ball effect, just using a volume texture. So that's sort of the 3 ways that we can define custom shapes. So in a minute we'll actually create an actor now, and we'll add this particle system in there, and we'll start to expose these parameters and add them to the blueprint so that we can control this much easier and in a much neater, nicer way, so it's all packaged into one actor, so we can just place these all over the world if we wanted to, and tweak them however we want per instance. So we'll have a look at doing that now, and then after that we'll talk about the height offset. So if we want to create a new actor, we'll just go to blueprint class, create a new actor, and we'll call this BP_interactive fog volume, and open this up, and we'll start to move some of this stuff into here now. So if we actually just go and get rid of this guy for a minute, and we'll add a new Niagara system, and we'll just call this ns_fog right, because that's what it is. We can make this the root of the component too, of the actor, sorry. Select the fog right component in here, compile, save, and if we drag this in, we now have our fog component as part of our actor. So in our material, this is all a bit of a mess now, so we're going to have a look at just tidying some of this up, exposing some of these parameters, naming them correctly, and adding them into here. So let's, this is our 2D texture. Move this over here, get rid of this. This here, this was our 3D texture. So we'll comment these, we'll just say volume texture. This is 2D texture. And this was our box here. So we'll actually just get a copy of these again, put them down here. And what we're actually going to do in here is we're going to make it so that we can switch between different custom shape types. And that's the first thing that we'll add in here. So we'll just have these as neat little packages. So this is our box, and then this was our sphere size. So this is our sphere. So for this, we set up this sphere mask with a fall off and everything earlier, but we will actually move this into doing this sphere calculation instead, because we'll just have a little bit more control over it. So we'll actually just get rid of this for now. That was actually some of our ground fog stuff, but we'll rebuild that in a minute. And we'll get rid of all of this actually. So we'll just rename this parameter here base, or no, not base, we'll call it global extinction. And then this will be our multiplier for any of our shapes. So we have our box shape, our sphere shape, our volume texture shape, and our 2D texture shape. Now we want to be able to switch between these, and a smart way of doing this is actually just appending all 4 of these together into a 4-channel vector, because these are only outputting scalar values each. And then we can just use a channel mask parameter to decide which one. It stops us having to use multiple static switches and all that kind of thing, which can get a little complicated sometimes if you have a long chain of switches, or a chain of multiple switches at least. So we'll just type append many, and we'll have a sphere. Now we'll just do it in order. We'll have volume texture in red, 2D texture in green, we'll have our box in blue, and we'll have our sphere in the alpha channel. And then if we drag off the RGBA and type in channel mask parameter, and we'll name this shape type, and it's defaulting to volume texture, but we'll actually default to sphere for now. And we will name all these correctly in the blueprint in a minute. And we'll drag this and we'll multiply this by our global extinction value. As I said, we'll come back and we'll actually rebuild the height fall off and everything afterwards in here. We're going to move this into the actor and allow us to define custom shapes, and then we'll talk about the height offset again when we start talking about distance fields and adding in the scene capture and everything. So that's all we need in here for now. So we'll save that out, and then if we just take a quick look at our instance here, we'll see that we have these values. So we have a value for our box size, our shape type, our sphere size, and we should also probably expose, in fact, the 2 textures that we're using, because that would make sense. Sorry if there was another slight cut there. I just actually ran into a problem which is worth talking about. Well, not necessarily a problem, but just something which can be a little confusing at first, which is that when we're creating these sample parameters for our textures, for a volume texture, which we're using here, if we right-click this and convert it to a parameter and just call it param, it says found volume texture requires texture 2D. So this won't actually allow us to sample a volume texture as a parameter this way. So undo this, and instead if you type in volume, and there's texture sample parameter volume. So this is what you need to use instead, and we'll just call this volume texture, and we'll plug our UVs into here and this into here, delete that, and this is how we actually sample volume texture as a parameter. It's a param volume, not a normal texture sample. So that's just something to be aware of. I often forget that that's the case, and as I did just now, I waffled on for about 10 minutes trying to figure out what was going on. So it's better to just cut that out, and that's how that's done anyway. So we now have our volume texture parameter, and we also want a parameter for this texture sample too. So we'll just convert this to a parameter, and we'll call this texture 2D. Click apply, and now in our instance we of course have access to change the volume texture and the 2D texture that we use. So these will all be the things that we expose to our blueprint. So let's jump into the construction script, because this is where all of this is going to be handled. So the construction script is just when you're placing actors in the level, when they're loaded, this is what's run. So like when you load your level, it will run the construction script, the actor will build or construct itself from this data, and then anything obviously that you want to do at runtime will be done in the event graph. So to start off with, we have our reference to our fog particle, but to actually change any of our material parameters, we're going to have to create a dynamic material instance. So that's the first thing we're going to do. If you just type in dynamic material and create dynamic material instance, so this will be the first thing we do, and we'll select the asset, and we're going to make it of type mfog instance, or you could do it from the master material itself. It's up to you, but we'll just do it from the instance for now. And we will then promote this to a variable, and we'll call this fog mid for material instance dynamic. So now that we have this, we actually need to apply that material to our particle, because currently our particle is just reading from the instance itself and not from this dynamic material instance. So to do that, what we need to do is open up our Niagara system again, and then under our user exposed parameters, we will add a material interface object parameter, and we'll call this fog mid. And now under our sprite renderer, you'll see that we have a material user parameter binding, and we can now set this to fog mid, compile that, save, and then in our blueprint we have access to our particle system reference here, and we will set a material variable. So set Niagara variable material, and the variable name is fog mid, and the object is our fog mid. So now this particle system is having its instance overwritten with the dynamic material instance, and we can then change these parameters at runtime or whenever we want through the blueprint. So let's have a look what we actually want to expose. So first things first, we will expose the shape type, but we want a nice drop-down selection like we have here. So for that, we'll create a new enumerator. We'll actually go through and we'll tidy up all this stuff at some point, but for now we're just going to have it sitting in this folder. So if you go to blueprints and enumeration, and just call this like e_shape type, or we'll call it e_fog shape type, just so that we can differentiate in case there's anything similar in the engine with that name. And we'll open this up. And all an enumerator is you can think about it as kind of like it's a state variable, so like a Boolean is, but Boolean can be true or false, it's a binary, whereas this is multi-input, so you can have many states. This is actually like a bit mask, if you know what that is. So we'll add some new entries, and the shape types we have our box, or we'll call this rectangle, because that's what it is really. We'll call it a rectangle. We'll call this one sphere. We'll call this texture 2D, and then we'll add another one and we'll call it volume texture. Save that, and then inside our blueprint here we'll add a new variable, and we'll call this variable shape type, and we want to make this of type e_fog shape type. We want to make this exposed so that we can edit it on the instance. Click compile and save, and now you see here we can choose from this drop down of different shapes, and if we're selecting our instance in the world, this will be under the default category, but we're actually going to add this to its own category so that we'll start to organize the things in the blueprint now. So we'll just call this category base shape, press enter, and that's now in a base shape category. And if we look here, we now have a category called base shape, which is exactly what we wanted. So we now actually want to make this change the shape that we're reading from. So we will also wrap all these into functions as well at some point, but for now we'll just string along in this graph. So we'll take the material instance dynamic, and we called our shape variable shape type in here too. So get rid of U. Now when setting a channel mask parameter, it's actually a vector 4. So if you type vector and set vector parameter value, and our parameter is called shape type also, and our value, so we want to set this to red, green, blue or alpha depending on what we've selected from our shape type list here. So if we drag off our color pin and type select, and not select color because that's from a Boolean variable, but this one, this will take in a wildcard, so we can use any kind of input, any kind of masking input in here. So we'll drag our shape type in, and now you see that we've been given 4 options. So when we select the shape type of rectangle, it will be whatever color we select here. sphere, texture 2D, volume texture. So if we look here, the volume texture was in red. So volume texture, this will be 1, and make sure that alpha is 0. Our 2D texture was in green, so 2D texture will be green 1, alpha 0. Then our box was in blue, so rectangle is blue. And then, of course, our sphere is in the alpha. So sphere will have an alpha of 1, 0, 0, 0, so we can leave that how it is. So if we compile that now and save, we look that if we choose our shape type, sphere, rectangle, we can actually change this, texture 2D, volume texture, and then we will expose obviously the other parameters such as the box size and everything to this blueprint as well. So now that we've got that, we will set another vector parameter value, and this is our box size, and make sure that you plug the material instance dynamic into here, and we'll create a new variable under the base shape here and call it box size, and make this of type vector. Compile. It might give you this error, can't pass default value. It's because it's trying to use an enumerator as its default value because we've converted it. So if that's the case, just type like 1 in here, compile, then it will recompile, and you can zero it back out again if you want to, but we'll actually set a default value of 200 for all sides in this box. Drag that in, get box size, and this will just convert to a linear color automatically. Compile and save. So if we change it to rectangle, in fact we'll call this, we're going to change this enumerator to box because I'll just keep forgetting, and it does actually kind of make more sense because a rectangle is a 2D shape. So yeah, now we have obviously our box size, and we can edit this through the blueprint too. We'll expose our sphere size next, and we did just call that sphere size, I think. Yep, sphere size. So back in here, this time a scalar parameter value. So type scalar, set scalar parameter value, and this is sphere size. And we'll create another new value in here, and we'll call this sphere size. You could put these into their own subcategories if you wanted, dependent on what shape type you select. So I might do that in a minute, but at the moment it's really unnecessary because you'd have sort of one variable in each subcategory, but something that we might do further down the line when we start adding a load more stuff. So make sure that this sphere size is a float. Compile, you'll probably get that error again. Drag this in here. And we'll just set the sphere size to 200 also. And that error goes away. Drag that in there. That's also exposed. Yep. So now we can also define our sphere size if we put our sphere in here. Now, this is something that does happen. When you're using Niagara particles, if you're dragging values in your construction script, the particle will disappear while you're doing that, but it will pop back up. This is just because the system is reinitializing itself a million times over as you're dragging this value, so things will disappear, and sometimes it might even disappear completely when you stop dragging, but it is still there and it will come back. You've just got to mess around with it a little bit. So that is something that I've noticed about particle systems. There is one way around this though, however, which we'll put in just for now. If we just grab this and then you force reinitialize at the end, then it means that whatever you've done, it will always end up visible again. So this isn't the case when you're just moving it around, but as you're dragging these values, then it will still disappear, but it will reinitialize at the end. So now we just want to expose our two texture parameters as well, and also our global extinction actually. So move, just get rid of him just for now. We want to set texture parameters. Texture, set texture parameter value, and we called these, one was called texture 2D, and the other one was just called volume texture. Volume texture. And these values, we'll just drag off here and promote these. So this value is going to be our texture 2D. Keeping the names consistent is quite important as well. It just makes things less confusing. And promote to variable, and we'll call this volume texture. Okay, right, compile, and we need to set these now. So the texture 2D is going to be our, where are we at, T star. And our volume texture, now this is expecting a texture 2D, I think. So we want a volume texture object reference instead. Change variable type. Okay, just unhook that for a second. And now we can select from our volume wisp, once we recompile, volume wisp, plug this into here, and make sure that you've plugged your fog mid in there, and that these two are exposed, which they are. Make sure that these are in the base shape category as well. You can just drag them in, or you can also select it from the drop down, or just type in here a category as well. Click save on that, and so this is also something that's worth talking about. These are in the same category, but there are now two of them, which is because, so Unreal's categorization when it comes to blueprints is unfortunately pretty broken. If you have a name that has a space in it and one without, obviously these are classed as different categories, but sometimes they can mix these up as well. If you have subcategories that have hidden variables in them, it will break the ordering. There's all sorts of things that sort of hopefully will be fixed with UE5, I'm hoping. But if you see what's happened here, there's two now. There's base shape and base shape. So make sure that these are in base shape and these are in base shape. We dragged these in and it created a new category with the same name, which is not exactly what we wanted. So now they should all be in here. Yeah, which they are. So this allows us to now define our shape type, as well as define the size of our box, our sphere, and the different shapes that we're writing to the textures with. So if we just now expose our global density parameter, then that will add our first into our sort of fog category in here. So we just called this global densities, or global extinction, sorry. So set another scalar parameter value, call this global extinction, promote this to a variable, global extinction, make sure that it's exposed, and we'll select it from the drop down this time instead of dragging it in, although this actually won't be in the base shape category, so that's my fault. Make sure that the fog mid's connected again. We'll come and neaten this up, like I said, at some point. And we'll just set this to 1 for now, and category for now we will just call fog settings, and yeah, that should be it. Save all of that. Yeah, so now we have our base shape that we can define, and we have the start of our fog settings, which at the moment is just our extinction, which we can change here. So I didn't actually realize how long this recording's gone on. I think that for now we will leave it here, and then in the next episode we can then really start to dive into the material, look at the height offset things and the noise, the self-shadowing, all of that sort of stuff. So I'm sorry if you're looking forward to that in this part, but this has gone on long enough already. So I'll see you very shortly in the next part, which I will be hopefully recording by this weekend. So thank you for watching. If this helped, please like and subscribe. If not, let me know why, and if there's anything you want to see in the future, just let me know in the comments, and I'll reply, and hopefully we'll be able to get something on the list. So thank you guys, and I will see you in the next part.